In November 2022, AMD launched the Radeon RX 7900 XTX, a flagship known for its ray tracing capabilities and power efficiency. By January 30th, 2025, NVIDIA introduced the GeForce RTX 5080, aiming to elevate gaming realism and AI acceleration. Both GPUs were priced at $999, making comparisons relevant in terms of performance and value. Let's explore their specifications to see which GPU comes out on top. Both the GPUs are built using the advanced 5-nanometer manufacturing process. However, their architectures differ significantly. The RTX 5080 utilizes NVIDIA's Gigabytes 203 architecture, which integrates 45.6 billion transistors within a compact die area of 378 millimeters squared. This design prioritizes computational efficiency and scalability, enabling features like enhanced tensor cores of 336 units and dedicated ray tracing cores of 84 units. On the other hand, the RX 7900 XTX employs AMD's RDNA3 architecture through the Navi 31 GPU, packing a staggering 57.7 billion transistors into a larger die area of 529 millimeters squared. Despite having fewer transistors, NVIDIA's architectural optimizations and inclusion of next-gen tensor and ray tracing cores give it an edge in future-proofing and adaptability. When comparing core counts, the RTX 5080 boasts a whopping 10,752 shading units compared to the RX 7900 XTX's 6,144. Similarly, the RTX 5080 leads in texture mapping units with 336 versus 384 on the RX 7900 XTX. However, the RX 7900 XTX counters with superior raster operations pipelines, featuring 192R OPs against the RTX 5080 112. These differences translate into distinct strengths. The RTX 5080 excels in parallel processing tasks such as AI inferencing and complex simulations, while the RX 7900 XTX shines in traditional rasterization heavy workloads like AAA gaming titles that rely heavily on pixel fill rates. Here the result is tied as each GPU dominates in specific areas depending on the workload type, balancing out their respective advantages. Memory subsystems play a critical role in determining a GPU's ability to handle high-resolution textures and demanding workloads. Here, the RX 7900 XTX takes a clear lead with its massive 24 GB GDDR6 VRAM, connected via a wide 384-bit bus interface. Running at an effective speed of 20 Gbps, it delivers a total bandwidth of 960 per second. Meanwhile, the RTX 5080 opts for a faster yet smaller memory configuration, 16 GB of GDDR7 running at an impressive 30 Gbps over a narrower 256-bit interface, resulting in a bandwidth of 960 GB per second as well. While both cards match in theoretical bandwidth, the RX 7900 XTX's higher capacity makes it better suited for ultra-high resolution gaming and professional applications requiring extensive datasets. Ray tracing and AI acceleration have become defining factors for modern GPUs. The RTX 5080 includes 84 dedicated ray tracing cores and 336 tensor cores optimized for deep learning supersampling and similar technologies. Combined with its higher clock speeds of up to 2,617 MHz boost, the RTX 5080 delivers unparalleled performance in ray-traced environments and AI-driven upscaling. Conversely, the RX 7900 XTX relies on 96 compute units adapted for ray tracing but lacks equivalent tensor cores, relying instead on software-based Fidelity FX super resolution. While FSR performs admirably, it cannot match the sheer efficiency and quality offered by NVIDIA's proprietary solutions. The winner, NVIDIA RTX 5080's superior hardware support for ray tracing and AI ensures smoother frame rates and better visual fidelity. Power efficiency is another crucial aspect when evaluating GPUs. The RTX 5080 consumes up to 360 watt, powered by a single 16-pin connector, whereas the RX 7900 XTX requires slightly less at 355 watt, but uses two 8-pin connectors. Both cards employ dual-slot cooling solutions. Though the RTX 5080's sleeker dimensions, 304mm by 137mm by 40mm versus 287mm by 110mm by 51mm, may appeal to users with space constraints. Additionally, the RTX 5080 benefits from PCIe 5.0 compatibility, allowing for improved data transfer rates and potentially lower latency under heavy loads. Connectivity options are essential for multi-monitor setups and peripheral compatibility. The RX 7900 XTX offers one HDMI 2.1A port, two DisplayPort 2.1 ports, and a USB Type-C port, a versatile selection catering to various devices. The RTX 5080 matches closely with one HDMI 2.1B port and three DisplayPort 2.1B ports, but omits USB Type-C. While both GPUs provide ample connectivity, the RX 7900 XTX's inclusion of USB Type-C gives it a slight advantage for VR headsets and external displays. At launch, both GPUs were priced identically at $999. However, considering their respective strengths, the decision ultimately hinges on user priorities. For gamers seeking top-tier ray tracing and AI-enhanced experiences, the RTX 5080 justifies its cost. Meanwhile, professionals or enthusiasts focused on productivity and large-scale projects might find the RX 7900 XTX's abundant VRAM more appealing. Given the advancements introduced by NVIDIA in the RTX 5080, it edges ahead in delivering commensurate value for its price point. Thank you for tuning in. After analyzing every facet of these two powerhouse GPUs, the NVIDIA GeForce RTX 5080 emerges as the overall winner. With superior ray tracing and AI capabilities, a sleeker design, and PCIe 5.0 readiness, it represents the pinnacle of gaming and computing technology as of 2025. That said, the AMD Radeon RX 7900 XTX remains a formidable contender, particularly for users who prioritize VRAM capacity and display versatility. Ultimately, your choice will depend on whether you lean toward bleeding-edge innovation or practical utility. What's your pick? Tell us why in the comments.